Okay,
That's funny.
so we're going to talk about balancing equations here. Are you ready? All right, so I don't balance equations like Miss Nandor and Miss Barkium, so we're going to talk about why. So why you would balance equations is to show conservation of mass, okay? And the reason we have to do that is because mass can't be created or destroyed. And so when you have your little chemical equation with your reactants and your products, the gist is that everything that's over here has to be over here somewhere too, okay? So you can't lose anything, and it's not that you have to have like two things added together have to be two things added together, but that all of the little pieces of the chemicals that you're talking about have to be in both sides. So your subscripts kind of change things up, so you balance the equation to make sure there's the same amount of stuff on both sides. So the how, I like to draw diagrams because I'm a visual person, and if I can see whether or not it balances, then I know what to do. And what you do is you add coefficients, and those are the big numbers in front. You don't change the subscripts. Don't change subscripts, because when you change the subscripts, you change it into something entirely different. So never ever change the subscripts, okay? And the method that I go about doing it is the first thing I do is I draw all the particles. And then what I do is I add particles, the whole particles, until I have the same amount of stuff on both sides. And then I count them up, and that is the coefficient that I write down. So I'll write that down, coefficient. Okay, so now how I draw them, there's a bunch of different ways that you can draw them, so we'll do some examples. Ow, I'm stuck. Okay. So this first one that we're going to do, it says N2 plus O2 gives NO2. And on here it's got a little G in parentheses. And that little G, sometimes you'll see that on equations. That just tells you the state that it's in. So this is telling us that we have nitrogen gas and oxygen gas, and it's making nitrogen dioxide gas. But that doesn't do anything for us as far as balancing. So I'm just going to scribble it out and pretend it's not there. So I've got these little blanks here that I'm going to fill in. That's where my coefficients go, okay? So the first one, I'll do an example where I draw shapes. So for N, I'm going to put a box, and for O, I'm going to put a circle. And so I'm going to draw my reactants and my products, and N2 means that I've got two boxes, so I'll put two boxes. That's the one particle. And they're touching, that's how I know they're a particle. And then I've got O2, so that means I need two circles, so there they are, two circles. And then I've got NO2, which is one box and two circles, okay? Now, sometimes to help me keep things straight, I'll circle my particles, because then that helps me remember that they're separate things, okay? It also helps me remember that when I add, I have to add the whole particle. So I'm gonna make a little note here, add whole particles. And you can't take anything away either. So the only thing you can do is duplicate stuff. So at first glance, my circles are good, but my squares are not. So I've got two circles and two circles, but I don't have two squares and only one square. So I need more on this side. So that's what I'm going to duplicate. That whole particle, though. I got to add the whole particle. So there it is, the whole particle. So now my squares are good, but oops, now my circles aren't. So now I got to add more circles on this side. So I'm going to add, again, the whole particle. And now I have the same amount of everything. So I drew them, then I added particles, and now I got to count them up. So I've got one of these, so I put a 1 there. I've got two of those, so I put a 2 there. And I've got two of those, so I put a 2 there. And so that is my balanced equation. So let's look at another example. Let's do this one. I'll be honest, I have no idea how hard this one is. I just randomly selected it, so we'll see how it goes. All right, so we got CaCO3, and it says it's a solid, and that turns into CO2, a gas, and CaO, a solid. Okay, so remember, we don't really give a crap about these states. They don't help us balance or not, so we can get rid of those. I am, let's see, for this one, I'm going to feel extra super lazy, and for CA, I'm going to put a dot, and for C, I'm going to put a line, and for O, I'm going to put a circle. And when I do this, it's harder to like stick them together, so I'm definitely going to circle those so that I can remember which ones go together. So I've got CA, CO3, okay, so there it is right there. And then over here I have C, which was a line, and O2, and that's one particle. And then I've got CaO over here. Now this one's a little harder because you can see over here in the products that you got the O's in different places. So when I count things up, I have to pay attention to that. Oh, this one's going to be far easier than I thought it would be. Okay, so dot and dot, though my dots are good, so my CA's are accounted for. And C, I've got one on each side, and then I've got 1, 2, 3 O's, and 1, 2, 3 O's. Hot dog, this one's already balanced. I love it when that happens, but it's not a good example because I can't add any particles. But so it's already balanced. I'm just going to write down that I needed one of those, and one of those, and one of those. That feels like cheating, but sometimes that happens. So it's already balanced the way it is. This one wouldn't actually need any coefficients, and that's okay. All right, so we'll do one more example. I'm going to get a new piece of paper here. This one's not quite as easy. We'll actually have to do some balancing here, I think. I hope. It'll be a little disappointing if I don't have to. No, I definitely do. Okay, so I've got CH4, which is methane, and it's a gas. I'm going to add that to O2, which is a gas. This is called combustion because I'm going to be burning the methane in oxygen. And it's going to make CO2, which is a gas, and H2O, which is water and a gas. And so this is what we got going on here. Okay, so let's see. On this one, I'm going to be somewhat lazy. I got C's, H's, and O's here. So my C's are going to look like a C, and my H's are going to be a line because I don't want to write, you know, the extra lines to make an H. And my O's is just going to be a dot because I'm feeling lazy right now. Okay. To be honest, it really doesn't matter what symbol you use. You can use shapes, you can use letters, nobody cares, okay? But you do have to make sure that when you draw things out that you get this right. 90% of the time when students have trouble balancing equations because they didn't draw the chemical right in the first place, like they forgot an H or they didn't distribute the little parentheses things appropriately. So now remember, we don't care about gases here. This doesn't mean anything to us, so I'm just going to get rid of that. So I got CH4, okay, and O2, and I got CO2 and H2O, okay. H2O right here is a common one that people miswrite. I don't know why. H2O, 2 H's and an O. Oh, I didn't draw my O correctly. It's a dot. Okay. So now I'm going to count stuff up. My C's look good. My H's are not. So let me add another H2O over there. Remember, I have to add the whole particle. My O's are not okay, but my C's are still okay. My H's are good. So I've only got to make my O's balance out. So I got 1, 2, 3, 4 of them, and I need 1, 2, 3, 4. So there we go. So when they're in different places, when you've got something in different places, save that element for last. Save element for last if it's in more than one thing. Okay, so if I had balanced my O's first, I would have had a little bit of a headache, but I started with my C's, then I went for my H's, then I saved my O's for last. Okay, that'll happen. That'll come up on some of the ones that you practice on. So now I just have to count things up because everything's balanced now. So I got 1 of that thing, and 2 of that thing, and 1 of that thing, and 2 of that thing. So that's it. That's all there is to balancing.